Hey and welcome. Today we will solve permutations interview question in a recursive way. Soon there will be a backtracking version as well. So let's jump right in. First example here, just a disclaimer. This video will be a bit mathematics involved, but if you landed to this video, I hope you already understand what permutations are. If not, please check some videos on that topic first to get you into the right context. There are plenty of people that can explain this so much better than me, to be honest. But if we get back to the leetcode problem now, in case of 1, 2, 3, as you can see here, there are 6 possible ways that we can arrange them next to each other, and our algorithm has to return them all. Second example, simple enough, 0 and 1, and there are only 2 possible ways that we can arrange them next to each other. And finally, a single value, which we might return it inside of an array. This is kind of edge case, and leetcode wants to give us a hint that it expects to get the result in a 2-dimensional array, even if we have single element inside of that. So let's see what we need to do. First things first, based on mathematical rules, permutations of n objects equals to n factorial. Of course, the original formula we see everywhere is this one right here, which refers to permutation of n objects taken r times. But it's better to note that there are 4 types of permutations, and the one that we are dealing with in this problem is the first one. I'll put a link in the description for a slide that I found it pretty much helpful in case if you're interested. But if we consider our array examples, if we have 3 elements in the array, we might expect 3 factorial possible permutation as a result, which is 6. If we have 4, we might return 4 factorial permutations, which is 24, and so on. So that's been clear. Now, one way to solve this problem is by using recursion, in which what we need to do is thinking about checking all possible combination of numbers that can be arranged next to each other. That means one by one, we have to put numbers next to each other, because literally, we've been asked to provide all possible cases. But how we might do this? We can perform a depth-first search on each number, because if we take a look at numbers we have in a tree mode, we might quickly realize that if in each breadth of this DFS search that we're supposed to perform, we remove the used number from possible choices we have, and we keep doing this until we reach to a level that we use all available numbers, what will happen then? Pretty much the picture is obvious, but the thing is, the pass for each value will give us our permutations. That would make sense, because in permutation, numbers should not be repeated. Only the position of each should change. And as a side note, and matter of fact, we will have 3 factorial passes for this example, as we discussed it at the beginning. But everything seems to be sunshine and rainbow so far until we get into the coding part. In code, we only deal with an array. The process looks simple enough though. We're supposed to take one number, plug it out into its array, and whatever remains will be rest of possible options to choose from, which indeed will form their own path. And finally, we will get into our answer when we ran out of remaining numbers to choose from. So this is the exact recursiveness part of our solution. We need to repeat this cycle of plugging out number and try the combination of that number with whatever remains in our hand until there is no numbers left, which would mean that we hit our base case. That is the point that we might declare that we are done with this path. And this cycle will happen again for other numbers in the array as well. We plug it out, form the path with each of other possible numbers, and repeat this cycle again until we hit the base case where we don't have any numbers left to continue. That would mean having all permutations in our hand, since we don't have any more numbers left in our main array to do this cycle again with it. Now, with all that explained, let's jump into the code to implement the solution. So the first thing to do is creating our result array and returning it at the end of this function. Next thing is going to be our DFS search helper function. We can either define it outside of this function or inside, but if we define it outside, we need to pass around the result array, since we will push our possible permutations inside of that. So we will define it inside and skip passing around the result array. What this DFS function receives as arguments are 2 things. First is a single array called possible permutations that we keep adding numbers into it, or better to say, we will form more permutation as we go deep in our call stack of recursion. So we call first one as possible permutation. Second is going to be the rest of numbers in array. In each level we go deep, but except that number we already used. This literally means we pick out one number in each level and try to follow new passes with each of numbers that has left, literally forming a pass for every possible option. So the second one will be rest. What will happen inside of this function is quite interesting. For each of numbers except the one that we used in each level, I mean literally the rest array, we will do a recursive call of function itself. That means an iteration over rest array first. And next thing we had to do is call the function, but with proper arguments. First argument is going to be plucking out the number we're supposed to use in that level of recursion as possible choice. But note that the first argument for our DFS function is the possible permutation. So we need to keep updating that argument as we go deep inside of our recursion levels, because at the end of the day, we need to add it into a result array. And if we lost track of previous numbers from previous recursion, we will not have the correct permutation. That means spreading possible permutation argument into first array alongside with plucked out number, the one we choose to be continue with. Then the second argument in recursive call for our DFS function will be rest of numbers except that one that we plucked out. So we will do the proper slice for that, and that will form our DFS search, but we are missing one really important thing, which is our base case for this recursive function. So the definition of base case will be when the rest array is going to be empty, right? As we discussed it in the slides, because that is when we have no numbers to choose as a possible candidate to continue the pass we are forming. So we will do a check based on that, and that is the step. We might notice that we are at the end of the pass, and the current pass we have is the full permutation, one of the possible permutations. Finally, return from that check since we are done with that pass. Now the only thing that left is to call the DFS function with an empty array as a first argument, which will then form our possible permutation, and passing nums array as second one, which will be used along the recursion levels. Now if I run this, test cases are passing, and if I submit, we are in a good shape here. Now let's jump into the time and the space complexity. For time complexity, we will have O of n times to n factorial, where n is the length of array, obviously. First n because of our for loop, and n factorial for the permutations count. For space complexity, it will be O of n factorial again, because we found n factorial amount of possible permutations. So that was it for this video. Just note that soon there will be a backtracking version as well. Please stay tuned for that one too. Thanks for watching, and please leave a like, comment and subscribe to the channel. I will put the link for arrays and mathematics playlist in the description to check it out if you are interested. And finally, hope you enjoyed this video and stay tuned for the next one.